Peace be upon you. Welcome to the chemistry session. Separation technique is our lesson. The objective that we learn at the end of this video is explain a separation technique that's used to separate solid-liquid homogeneous mixtures that's known as simple distillation. Recalling back, mixtures are of two types, heterogeneous and homogeneous. Heterogeneous mixtures could be solid-solid, liquid-liquid, solid-liquid. Separation techniques used for solid-solids are magnet picking and hand sorting, while for liquid-liquid heterogeneous mixtures we have decantation using separatory funnel. For solid-liquid we can use decantation, filtration, or centrifugation. And for solid-liquid homogeneous mixtures, technique known as crystallization. Simple distillation is a technique used to separate the constituents of solid-liquid homogeneous mixture. It's based on the change of state of the liquid constituent in the mixture. The simple distillation technique is represented in the adjacent figure. Starting from thermometer, flask where we place our homogeneous mixture, a Bunsen burner, a condenser, and the distillate that's collected inside the Erlenmeyer. Watch the video twice and don't forget to take notes. Before we are going to study how does the simple distillation work, first of all, let's see the condenser, which is the most important equipment used in this technique. The condenser is made up of two tubes. The inner tube that has this opening and this opening, and an outer tube with these two openings that will be attached to the rubber tube. To check the inner one, I'm going to blow in the inner tube. Look at the water vapor inside it. Do you see? This is the inner tube. That's starting from here, and this is its outer. How does that simple distillation work? First of all, we have to open the water source. Look here, the water is passing in the outer tube and get out from the other opening. Look here. Turn on the Bunsen burner, play the wire goes, and observe what's happening inside the round bottom flask where I place my salty water mixture, which is a homogeneous mixture as you see. First of all, we'll wait till this mixture starts to boil, and we'll observe what's going on inside it. As you see, what is this? Yes, it's a water vapor. The water starts to evaporate as you see. Let's look at the round bottom flask where I place my mixture. The mixture starts to boil and the water evaporates, filling in these places, the empty space here as you learned in a physics session, going in these tubes, passing the inner tube of my condenser as you see. In this condenser, the water that's in the outer tube will cool down the gas passing through the inner tube and change again into liquid as you see, collecting this liquid in this beaker. This process that takes place inside the condenser is known as condensation, and we'll collect everything inside this, every liquid inside this beaker, okay, till all my liquid evaporate. To obtain them as distillate, leaving here as a residue the salt that we'll see later on when all the water turns into liquid. Okay, at the end of my experiment, look here at the salt that's obtained here at the wall of the round bottom flask, and the evaporated water goes and it's collected right here in the beaker. Look at this is my distilled water, it's a pure substance, and here is my salt. Well, before answering, what is the role of the Bunsen burner? Look, this is the Bunsen burner. Look at its top. What is its role? Very good. Heat the mixture. Which constituent of the mixture undergoes a change of state inside the flask upon heating? Good. The liquid constituent. What will be the physical state of the liquid constituent upon boiling? It will turn into... Yes, into a gas. Nice. Observe this figure and tell me to which part of the distillation setup the gas formed is conducted. Good, to the inner part of the condenser. To which state the gas changed inside the condenser? Think well, to liquid state. Nice. What is the role of water passing in the outer part of the condenser? Remember, get the water in the outer part passing from the lower part of the condenser to the upper one will cool down the vapor that's passing in the inner tube of the condenser, and the vapor changes to liquid state. Indicate the physical state of the cooled water vapor in the condenser. It will change into liquid, and it's getting out from the condenser as a liquid. What do you obtain in the round bottom flask at the end of the distillation? Observe, what do we have here as a residue? Think. Salt. It's solid residue, which is here a salt. Nice. Let's check what is the difference between boiling and condensation. Look, the first one is a boiling. Nice. Boiling is the passage from the liquid state into the gaseous state. Check condensation and try to define it. Nice. It's the passage from the gaseous state into the liquid state upon cooling. Oh, no. Did you notice that these two processes have opposite meanings? Look at them. They are opposite. Give the name of the change in state that occurs in the flask. Look at the flask in the figure. Yes. What's taking place inside the flask? What is the change of state? Boiling. Good. What in the condenser? Look carefully inside the condenser. What's happening? Condensation. This is its change. Let's recall back the physical properties. Density, boiling point, size of particles. What do you mean by the density? Let's recall back. Density, when I put water and oil, they didn't mix together. Since water is more dense, so it will settle down. While, what do you mean by boiling? Look at the picture. Good. The mixture starts to boil at definite temperature after placing it on a heat source. While, what about size of particles? Look, what are we doing with the sieve here? The particles of constituents of the mixture have different sizes. On which physical property does the implicit distillation technique depend? Density, boiling point, size of particle. Look at the figure carefully. Oh, the water boils and passes to the gaseous state where we have formation of bubbles. Then what should be the physical property? Think. Good. It's boiling point. Nice. Then the liquid with the lower boiling point vaporizes first. Note, the constituent of a sugar-water mixture can be separated using this technique, since upon heating sugar, water will caramelize. Let's recall back to fill in the chart. Mixtures could be heterogeneous and homogeneous. Separation techniques used to separate solid-solid heterogeneous mixtures are magnet picking and hand sorting. While for solid-liquid heterogeneous mixtures we'll use decantation, filtration, and centrifugation. And the lone separation technique for liquid-liquid heterogeneous mixture is decantation using separatory funnel. While for homogeneous mixtures, we could use either crystallization or simple distillation. It's evaluation time. Don't forget to stop the video before you show the answers. Let's take an evaluation. The figure below shows an apparatus used to separate miscible oil and ester. Observe it carefully to answer the following questions. Look at it carefully, at the chamber, at the refrigerator, in order to answer. Name the physical change of state that takes place in chamber. Look at the chamber. Yes, we use a heat source. What's happening inside it? Boiling. Good. While in the refrigerator, where you use cold water. Yes, condensation. Indicate the type of the mixture of oil and ester. How many phases do you observe? Yes, how many phases? Justify your answer. Good, it's a homogeneous, since oil and ester are miscible. The principle of the above apparatus resembles one of the techniques that's used in the laboratory. Let's take a deep look. Chamber, where we place the oil and the ester, exposing them to fire. They boil, and upon boiling, the evaporated gas passes through the tubes that's surrounded by cold water. Good! It seems to be like simple distillation. Nice! Now, let's make a comparison. Name the equipment of this technique that resemble the chamber. Look, in the chamber we place our oil and ester, expose them to fire. Nice, it seems to be like flask where we place our mixture and expose them to Bunsen burner. Good. What about refrigerator? The gas passing through the inner tube surrounded by cold water. Yes, nice, condenser where the gas passes through the inner tube and surrounded by cold water in the outer. Prepared by Amani Sablani, recorded by Amani Sablani, and supervised by Dalal Bais. Thank you for your attention and take care.